And we'll test the smart contract after instantiating it and make sure it works as we expect. So we'll get into testing by going neutron-d query, and we want to query the WASM. Again, if you don't know what the subcommands are, just $help and you'll get all the subcommands you need. So neutron-d query WASM. And what are my options here? They're various. And what I actually want is contract state. These are querying commands for the WASM module. All these other things are definitely useful. I can get contract info, for example. I'll show you now. If you need to know, for example, the code or code admin of a contract, you can ask, hey, I just want this contract. And we called it what? Learn counter contract. And it will give you some information on the contract, the admin, the code ID, and so on, as well as that label we entered. But I want the contract state. I want to ask it what its current count is. So when I query my contract state for WASM, I have three options, all, raw, or smart. And you'll almost always use smart. I want to make a smart query on my learn counter contract. Now this is going to throw because it will say it accepts two arguments. The two arguments it accepts are not just the contract address, but what I want to get. See the address here, but also the query. And the query is there's not any help here, but you just ask for what you want in a JSON format. I'll show you the example for count. I can ask it to give me the count like this. And I really wish that was on another line, so let me put it on another line for you. Let's do that. All right, so now I am querying and asking it in this serializable format, please give me the count. And now I'm faking that I don't really understand the contract when I do this. And this is a valid way to approach an open CosmWasm contract. I guessed that count was the way to get the count, and I actually get the variance here. If I had bad or something here, it would say, no, I expected get count. Or if it was a number of options for query, it would list them out for me. So I can kind of gain some information very simply that way. Now I call get count and it replies with the data, count is 420. And that's because over here in our message struct over here, we don't just call this count, we called it get count. And if I changed this to count and then recompiled, re-uploaded, reinstantiated, then it would reply to count. But with get count, you'll notice also that this is in a different case here with capital initial letters, whereas this is in a snake case and has underscores instead. And that's by design, and it's part of this CWSerde macro that does that conversion for you. So where you see this format, the camel case format here, you see the snake case format over here whenever you pass in queries from JavaScript or from command line. So let's now come in and do a TX WASM. And one of the options here is execute. That's what we'll be doing. TX WASM execute. Now execute has some options. It's going to ask us for the contract and the message we want to execute on. And we'll have to also specify who's doing the executing using the from flag. So I want to execute on the learn counter contract. I want to execute increment. It doesn't have any parameters, so I do it like that, much like the query. And it's from my testnet counter account. All right, I confirm the transaction. And now I get this TX hash back. Let's see what happens when I query it now and ask it what the count is again. Now it's 421 on testnet. So successfully incremented. Now I need another account by this point. So I'm going to create a new key and I'm going to call it bad actor. All right, I now have this bad actor key. I'll need to send it some funds so we know it's failing because it's not allowed to reset rather than failing because of funds. Neutron-D transaction, bank send from testnet counter, send to this address. And I need to send an amount. I'll just send 0.1 or 100 U neutron. Now if I neutron-D query the bank balances for that address, it doesn't have anything. So the transaction failed. Let's see what's going on over here. I'll go to mint scan this time. Out of gas. Gas wanted. We ran out of gas. I didn't specify enough gas. So the gas specification, the gas limit is too low for this send operation on testnet. So I need to do it with a better gas estimate. I'll just do this with a gas adjustment of 2. Okay, let's see if that went through. Yes, this time it succeeded. So the gas was a little too high. And now if I query the bank balances for my bad actor address, I have 100 neutrons. So now this is the bad actor address. I have 2 keys locally. I can always check with neutron D keys list. And you see I have this address that is called the testnet counter. We've used it for admin, and it's a good actor. It's the owner of the contract. It's the code admin of the contract. It can reset the counter. But this bad actor, it can increment the counter, but it can't reset the counter. So let's make sure that that behavior is as intended. Neutron D, TX WASM execute, increment, right? We're going to increment from bad actor, and that should work. Canceled transaction. Let's try again. Okay. Spendable balance neutron is smaller than insufficient funds. All right, I don't have enough funds for the gas, so I will send more funds over. Looks like we need 20,000 U neutron or micro neutron. We'll send over 80,000 U neutron to the bad actor address. And I'll check the balances again to make sure that that came through. It did. Okay, so now my bad actor has enough gas to do what it needs to do. And what I wanted to do was this. The bad actor increments the counter in the learn contract. Go. Okay, I have a TX hash now. TX should be successful. If I come over to mint scan, put that transaction in, there it is. It's been indexed. It's a success. And you can even come in and see what have we done? We've incremented. That message was increment with no funds, and it was coming from our bad actor address on our contract. So that's fine. And if I come in and ask the contract now, what is your count? I should get 422 because the testnet counter incremented and then the bad actor incremented. Perfect. Now where it gets sticky is the bad actor should not be able to reset this count, but the owner, the testnet counter account, should. So let's create a new execute statement here where we're not just incrementing, we're doing a reset. And if we go over and look at our code messages here, our execute messages, we see that reset takes 1 argument. It's a count. Again, it's not going to be a string. It's an I32. So I'll come back and reset, and I'll set the count to 123. The bad actor is trying this. Unauthorized. I didn't get that whole sign. The node simulated and said, nope, you're not authorized to do this. Execute message failed. But if I come in and try it with the testnet actor, or excuse me, testnet counter key, then it appears to work. I can verify that by querying my contract state again and asking it get count. It should say 1, 2, 3. So the testnet actor was able to push this transaction through where they resetted the account, they reset the count to 1, 2, 3. But when the bad actor tried to come in and reset it, it didn't work. So the bad actor, all the bad actor can do is come in and increment the count, which works fine. If they increment the count, can sign the transaction, and now it should be 1, 2, 4. But the bad actor can't reset it. Only the testnet counter account can reset it. By this point, we verified that our contract works as expected. And if you have additional modules that you built in as you extended the contract, come in and test your smart contract on testnet to make sure it works. And if you're submitting it for the automatic tests, then really make sure it works and passes those tests by running these execute and query messages. Try to execute things, make sure it works as intended, query, make sure the state is updated as you intend, and then the automatic tests will just do that and ensure your contract is crafted and submitted correctly. And once you make it that far, congratulations. Not only have you learned all the main concepts for Rust smart contracts, you've also tweaked a smart contract, added some functionality, deployed it to a real network, and passed tests on that network. So I look forward to seeing what your extended contract submission looks like. Look forward to see it passing the tests, and looking forward to see what kind of great features you add to smart contracts in this course and in the future. That's the end of Rust for smart contracts. We've deployed a smart contract, make your final submissions, and then get ready for the next course where we dive into the details of COSM WASM. As always, the best way to view these courses is over at heretolearn.xyz, where we have quizzes, interactive exercises, graded exercises, and so on, all on one convenient platform. I'll hope to see you in the next course, and good luck as you continue working on learning Rust smart contracts.